Why does everything in functional programming need to be first class? And what does it even mean to be first class? That's what I'm going to be talking about today. My name is Eric Normand, and these are my thoughts on functional programming. So, before I talked about how there are the three domains of functional programming. There's data, calculations, and actions. And I mentioned that one of the minimum requirements to do functional programming is that you can make those three things first class. And I didn't go into very much about what that means. What does it mean to be first class? Really, it means that you should be able to have, in one sense, a pointer or a reference to the thing and use it as a value that you can pass to calculations, that you can store in data, that you can return from calculations. And so this is the foundation of it. So just like you can pass an integer around, or you can pass a string around to functions in your language or to methods, you need to be able to make an action and pass that to a function, pass it, store it in a variable, something like that. Put it in a collection. You need to be able to have a handle on that. And that is what allows for functional programming to do composition, right? So let me back up. In an imperative paradigm, when everything is a sequence of actions to take, a list of steps, the way you compose is by, in the code, writing, do X, and then under that you write do Y, and then under that you write do Z. And so it does those three things in order. So the main composition, the main way of composing is through sequencing those actions. Okay, and so even if you have multiple threads, you'll have a step that starts a thread, and that's an action, right? And so then things start happening in parallel, but each thread is sequenced, it's a sequence of steps. Okay, so the thing is, that's not first class, because those steps are not something that you can have a pointer to. I'm not talking about a pointer to the code. I'm talking about making it an object in memory that you can use somewhere else, right? So a classic example is that in Java or JavaScript, or most languages really, the if statement is not first class. It's just some syntax in your language that that gets compiled into some machine code, and that's the end of it. But in a language like Smalltalk, the conditional was actually a method on an object, right? And the object was the thing you were testing. So, for instance, the object that represented the value true would, if you called if true on it, it would call the first block that you passed it. That's the then. And if you call if true on false, it would ignore the then and call the else, right? So in that way, it was a method that you could then refer to somewhere else. So you could say that the conditional was first class. Like, there was nothing in Smalltalk besides message passing. Okay, and so in a language, in a functional language, you need to be able to make stuff first class. Now, usually a language already has first class constructs. As an example, in JavaScript, functions are sort of the savior of the language in terms of doing functional programming, because you can always wrap non-first class stuff up in a function. So in JavaScript, the plus operator, addition, is not first class. Multiplication is not first class. There's no way to refer to that plus symbol except in a mathematical expression. You can't pass it to a function. You can't return plus, right? It doesn't do any, it's invalid syntax. But you can take that plus and wrap it up in a function. So you can do function plus, and then two arguments a and b, and then return a plus b, right? And so now you've recreated the plus as a function that you can now, it does the same thing as the plus operator, except you have to call it like a function, but you can pass that around, and you can return it and whatever. So it's first class. The same thing happens with actions. So you have an action like print to the terminal, right? Or send an HTTP GET request. Those actions could be wrapped in a function. So the function has 0 arguments, and when you invoke that function, it will send off the GET request, right? And so you don't have to invoke it, and you can choose when to invoke it. It's just kind of bundled up in this function, ready to go. Now, we've talked before about the problems in languages like JavaScript and Clojure, where the language doesn't help you so much in determining what is an action and what is a calculation. So you have functions representing both your actions and your calculations, and so those can get confusing. But the same rules apply, the conceptual rules, that two actions, when you compose them, make a new action. But an action and a calculation and a calculation make a calculation, but an action and a calculation make an action. So we talked about this before, that actions kind of infect the other stuff, and calculations infect the data as well. So why do we need to make stuff first class? The real reason is you need to do real functional programming. Okay, in the sense of getting past the trappings of immutable data and data transformation and stuff like that. That's very important. But you don't get to the next level unless you have higher order functions. And higher order functions simply means functions that are operating on other functions. And I'll also include, just speaking loosely, I'll also include functions that operate, so calculations that operate on calculations and actions. Okay, so what does this mean? It means that you can, instead of an imperative where you have the way you compose actions is just through sequencing it in the code, you can actually have two actions and pass them to a function that makes a new action that sequences them. Okay, everything has to be first class to do this. If you don't have a way of passing the actions to a function, then you don't have a way of returning a new action. There's no way to do this. And this lets you do interesting higher order stuff. You don't have to write every function out. Or, like in JavaScript, JavaScript is a bad example because you can always wrap an action up in a function. In a language like C, or BASIC is maybe even a better example. When you're creating these actions, there's no way to pass an action to a function and have it return a new thing that sequences the two actions, right? You have to write out every sequence that you want. Now you can do it hierarchically, right? You can have subroutines and stuff like that, but still you're writing it all out. Whereas in a functional language where you have higher order operations, those things can be done dynamically. They can be done, you can have sequences of actions that were never written in code. You have code that generates those sequences. Okay, what's an example? You could have a program generate every possible action. I'm gonna use my hands. Yeah, every possible action. So let's say this is 1,000,000 different possible actions. Filter them for the ones that are valid. Okay, so now there's only 10, and then run those in sequence. How does it determine if it's valid? Well, it's got information about the environment that it's in now, right? And so you're dynamically generating this list of 10 actions that are valid, and then you can run them in sequence, right? You can't do that unless it's first class. Those are some of the things that we do in functional programming all the time. I should mention monads. Monads in Haskell and other a lot of languages use monads. Scala uses monads. They are a way of composing actions. That's not the only thing monads do, but in the IO type, which is the action type in Haskell, that is how things get sequenced. They are a special type that is recognized by the runtime as these are actions, right? So you could think of it as there's one part of the language that it just sees this as another data type that happens to implement monad. And so when you use what's called the do notation, which is a way of writing out monadic code, this is shorthand, like a syntactic sugar for writing out monad operations. Wow, this is getting deep into Haskell, and I don't know if I wanted to get this deep into monads right now. But monads are a way of composing values together, and Haskell uses IO, which has a monad instance, which has a way, you can use it like a monad, and so you're actually composing actions together that way in Haskell. And this is there is no okay, so in Clojure and JavaScript, even if you're writing in a functional style, inside of a Clojure function or a JavaScript function, you can always list steps. Very often we just have one expression in there, but you could list steps and they would happen in sequence. In Haskell, there is no way to do that. There's no way to list steps. What you do is you use, excuse me, there's a bug. You use monadic composition to sequence steps. That's all I wanted to say. That Haskell has this notion of first class actions. And a way to compose them up. And monads is one of the ways composing them up. Yeah, that's all I have to say about first class values. It's very important to have first class values. You want to be able to get to a higher order. That's where a lot of the benefit of functional programming comes from, is that you're writing code that composes sequences of actions. Or, another, I didn't mention this, but higher order functions can also take functions. So you can have a calculation that takes calculations. Common example, map, another one filter, another one reduce. These are your three workhorses of functional sequence transformation. And they all take functions as their arguments. And they let you reason at a higher level, write code that separates concerns out very well. You're separating out the sort of iteration through the loop, through iteration through a list, and what you do to each element of the list. How you build up your list. So you're passing in to map the function that says what to do to each item, or you're passing in to filter the function that says which items to keep. And so the filter logic can be done once, written one time, and used in many, many cases. Same for map. This idea of building a new list based on an old list with all the elements transformed, that can be written once and reused many times. And this allows us to have code that is reusing stuff that in a language without that first class, you would be writing inline every single time, like a for loop or something, right? Like, how many times have you written a for loop that takes one list and changes the elements of the list in the same way as, for each element in the list? It's such common code, and there's almost no way to get rid of that unless you bring it up to a higher level where you can pass in that body of the loop as a function, right, as a calculation. All right, so that's the other part of being first class, is getting to higher order functions, not just ability to dynamically sequence actions, but also to have higher order functions. And there's plenty to talk about higher order functions, which I'll get to in another episode. So if you want to hear about that, please do subscribe, like it, star it, heart it, thumbs up it, +1 it, do what it says, favor it. What else is there? I don't know, high five. Does anyone use a high five? Do that one too. Anyway, this has been a pleasure. My name is Eric Normand. These have been my thoughts on functional programming. See you later.